Dr. David Kirtley. I'm with MSNW. We're a small research lab out of Redmond, Washington. And we focus on Department of Energy fusion research and Department of Defense and NASA space propulsion research. The main goal for our program, which is a plasma aerocapture technique. It's a new plasma aerocapture technique. And the main goal will be to demonstrate the fundamentals of our technology concept. And so this is when a spacecraft is coming in to a planetary orbit and it's on a hyperbolic trajectory, or it's entering into the gravitational area of a planet, and instead of using propellant to actually brake or to slow down to get into orbit or to even get into low orbit and start descending, you use the atmosphere itself to brake. So you use the neutral particles and the gas for the very high altitude rarefied gas to brake on. Now in traditional technologies, you use a physical shell, a physical high temperature ceramic or some other type of barrier to brake on and to actually decelerate. What we're doing is a little bit different. What we're going to do in this idea is that you tow a plasma sphere behind your spacecraft. And so what that really means is that we're going to tow a large high power magnet, not a superconductor, but a couple hundred watts worth of magnetic field. And it generates a magnetic field in an interaction region that's about 50 meters in diameter. We fill that with a magnetized plasma, so a really high temperature gas that is so high temperature that it's ionized, and that we can use the electromagnetic effects of that gas to interact with things. And in this case, what we're going to do is we tow this orbital velocity hypersonic parachute, plasma parachute even, through this atmospheric gas at very high altitude. So in Mars, we talk about like 100 kilometers, or in Earth even higher. The neutral gas, as it's coming in, interacts with this plasma and does a collisional process called charge exchange. Charge exchanges with these neutral particles, and then we trap the gas. So unlike a shell where you're deflecting it, we're actually going to have a sort of a fluffy parachute, fluffy plasma parachute, where as the neutral particles come in, we trap them for a little while, and then they stream out, but in the process it slows down the spacecraft. The benefits, there's sort of two paths that we see. And the benefits all come from being able to get to a planet and slow down and do it with not a lot of extra mass and not a lot of propulsion and not a lot of propellant. NIAC is a wonderful organization and a wonderful addition to, or I guess re-addition, as it were, to the NASA low technology readiness level package. And so NIAC encourages very rapid, very innovative ideas that are also high risk. And so, and that's perfect where this technology falls into.